Well, welcome to this afternoon's first wireless happy hour with our friends from Jetwave Wireless today. One of the things I am loving, there we go, Josh is getting into the mood. Enjoy, this is one of the things that I love about our industry is the ability to come together, converse, talk. Even if we're not out on show site, catching a dinner, catching an end of show drink, we have a unique relationship in our industry that so many others don't. So I think it's a pretty cool thing. Obviously, we're seeing a lot of diverse backgrounds today: houses, garages, basements, and then there's Pete Step and Repeat, who apparently is going to have a whole A-list folk coming through with his red carpet later on. So we'll all be looking for that on one of those other shows. But our topic on this one is specifically Wisycom and the products and field applications. So I'm just going to get this out front right now. Jetwave Wireless is not Wisycom. Wisycom is not Jetwave Wireless. Yet they have such a great relationship about that illustrates the power and influence that the end user or vendor can have with the manufacturer in a really positive way, and to come up with super neat applications that maybe at one point were a bunch of little black boxes that became one cool single black box, if you will. So Jim, I'm really excited to hear about the insights you have and your team and the hardware you're using. We've all heard the name Wisycom. We throw it around a lot, just Wizy this, Wizy that. They've emerged really in our industry as a true problem-solving product. But so many times when you hear problem-solving product, you think little box, right? Very specific, niche little function. And I think the Wisycom product has taken that, with a lot of input, from you folks in how we're using it in the show environments we all do, to integrate and create this this complete thought, I like to call that, right? When you have a box that has everything in there. We've also gotten so used to software control of hardware. Well, that's, in the day when you just had hardware and you had a bunch of push buttons, engineering was different for that. Now we need all the push buttons, but they need to be software, controlled push buttons. And then, oh, by the way, I need a GUI on that, right? If you get a nickel for every person that wants a GUI. And graphical user interface, by the way, I'll just make sure I'm not throwing around terms that's or anything. But before we actually jump into this, Pete, why don't you kind of talk about the Q&A process on this one, because I think we're going to have some unique questions that arise around some of these apps.
Sure. There's a question tab on your webinar control panel. Open that up and you can type in a question. You won't see all the, excuse me while I choke, you won't see all of the questions that everybody enters, but we will pass on the questions to the group of people, and they all have display screens which show the questions on them, and they'll at points stop and take questions or answer a question if it's relevant at that moment. Back to you, Kelly.
All right. So I think, Jim, I'm going to toss it over to you to introduce the team. And, a lot of times we hear a lot of names around in the industry. And for today was my first time of putting a face to some names that I've known for a very long time, and those kind of things. But maybe walk us through just a little bit of background about Jetwave. I did allude to the fact that you have a really strong relationship with manufacturers, and you're really you have a very strong engineering background in your team to begin with. So maybe just share a little of that, share the team, and then we'll get into the presentation.
Okay, sure. Thanks, Kelly. So yeah, we started Jetwave in 2014, and the whole concept of Jetwave was to innovate the wireless space. That was the point, is that I had been working for other larger companies that had a bigger scope in terms of what they were trying to do as a company, and I just personally felt being on the front lines of RF for so many years that there were problems that we needed to solve as end users. And the guys that are on this call are actually all guys that shared that same sort of vision and really shared pain in a lot of ways. It's just being on the front lines and having a common joke for us is that, and I hope this doesn't come off the wrong way, but production is always kind of on some level trying to kill us, right? Like they come out with a rundown at 7 o'clock in the morning for a show, and then they come back out. And so you set that show, and then at 7:30 they come back with a very different rundown, and now the show is all very different. And if you're an RF guy, the impact can be pretty stressful. And so a lot of what distributed antenna systems are about, and Jetwave, and this sort of pushing the envelope in solutions and living in the solution and innovating has to do with being so connected to the problems of doing shows in general. So on the panel here, the guys at Jetwave, all staff guys at Jetwave, we have Josh Flower, who has a long history in New York with Clear Brothers and with going back to Wireless First, and is an RF and comms guy all in one, which as well as Dave and Ryan. Dave Martin has been with me kind of at my side for the last almost 10 years, I think now. Dave and I used to build a lot of custom products, which preceded a lot of the products that started to evolve in our relationship with Wisycom, the manufacturer. And then our most recent addition has been Ryan, who we have been friends with and worked with as freelancers side by side doing shows for another long period of time, at least 10 years or so. And we were like super stoked when Ryan kind of appeared on the radar, and I wasn't as aware. And Josh and Dave were very big lobbyists to get Ryan on the team. So now I have to tell you, and it's humbling for me because I am so grateful to be a part of these three guys' lives on a daily basis. They are able to do things now that I could never do, and I'm probably 20 years older than all these guys, and so I really appreciate like what they're bringing, something really fresh to this, and they remind me of how I felt like when I was a lot newer to this. Not that I'm ready to go to the glue factory, as our friend Kevin Parrish would say, but I've been doing it a long time, and it's just really, really refreshing for one, and it just gives me a lot of gratitude and to be a part of this and to see these guys kind of taking it to the next level. They're sort of taking even what like Pete and I have been around for a long time. Pete was here when I got here. I'm going to be gentle. And when I started working at Systems Wireless in 1991 in wireless, that was my introduction to this. I was an audio guy before that. And Pete Erskine was actually one of the guys that was our customers back then. And so
just for the record, I'm 20 years older than you. So
okay, yeah. So we there's almost like 3 generations of RF guys here, which is pretty cool because there's a continuity in this story, and there's some goggles on the evolution of wireless. I think that you'll see, on the web right now, everybody's jumping on and doing webinars about everything, and there's a lot of very PowerPoint-driven presentations on, signal to noise and the ABCs of RF and all that stuff. And I don't think that's what we're going to do today. I think we wanted to do this. We called it a little bit of a happy hour because there's some really unique people here, and I think we'll make this a little bit fun and a little bit spontaneous, and we'll talk about some of our experience as it relates to the deep end of some of this distribution stuff. So thanks for being here, and looking forward to it. Thank you.
All right. Well, I think we'll turn it over to you guys. Josh, are you driving this one?
Yeah. So we'll move on from here and just discuss some of the, the topics of the day. Those being DAS, distributed antenna systems, RF transmission, and RF over fiber. The first thing we were going to touch on was distributed antenna systems and what they are. What does that mean? You're going to hear us refer to it as DAS, first of all, more often than just calling it distributed antenna systems. And then from there, we'll move on to RF transmission, talking about in-ear transmitters, and transmission distribution. Then from there, we're going to end up with RFoF fiber, which is one of Jim's personal favorite ones, because he has a lot of history as to how we got there. Distributed antenna systems, questions that would be asked, challenges to it, versus the benefits and whatnot. When we're looking at what is a DAS, it's exactly what it sounds like. A distributed antenna system is a system that is usually designed to allow for the consolidation of rack equipment, transmitters, receivers, communication devices. A backbone of antenna cable or fiber is going to run throughout your venue, your studio, whatever your space is that you're trying to cover, which you're trying to cover with your peripheral devices, those being your microphone, transmitters and handhelds, your body packs, your in-ear monitors, your IFBs, all that stuff, all coming back to a centralized location, which is usually going to be where audio is also going to have some part of their distribution too. So that's how we're going to get to their consoles and whatnot. So the challenges in it, and Jim, we'll pass this over to Jim in a minute. He'll talk a little bit more about the challenges more in depth, but just some bullet note points here. Challenge, no band plan, or congested areas like New York City. When we have five TV channels of space to work with, but our clients continually want to put anywhere between 150 to 1,000 frequencies in a facility. How do we fit that? How do we stagger all that space in there, and how do we make it work? That's pretty key to this. And at the same time, we're not going to dive too much into spectrum and whatnot. That's been covered pretty well by our friends at PWS on some other webinars. So we're going to try to stick to the system layer here. Challenges, what is your coverage area? You got to know, is it a big area, a small coverage area? Is your inventory kind of fragmented and separated all over the facility currently? And what's the plan to modify that so everything comes into the centralized location? And if you're dealing with a live studio, you got to figure out a transition plan to work with them if they're live. If it's a live news organization, we have to transition possibly overnight and then go live. A lot of our testing sometimes is going live. Like Bill O'Reilly said, fuck it, we'll go do it live. The benefits of it, RF inventory is a shared resource. Everything, everywhere, anything, anywhere is a huge benefit of this. It makes your inventory much more scalable, because then you no longer have to worry about expanding your antenna coverage systems, because those are already factored in. You don't have to put up little satellite systems around the facility. You just plug them into the master DAS, and they're already halfway there to anything, anywhere. Remote monitoring is a huge thing with software. The ability to see, what we're going to jump into here with the Wisycom stuff, how you can see and monitor your antenna system now, instead of just relying on turning that power switch on and seeing what's coming through. Your spectral efficiency will raise, because you can now treat the whole space as one instead of a bunch of breakout rooms. And you're going to look a lot better for doing this. System design considerations. Coverage, what are your coverage requirements? How many zones are we talking? How many studios are we trying to cover? Is transmit and is receive needed in all these zones? Is intercom required in these zones as well? What type of intercom? UHF, DEC 2.4, 5 gigahertz. These are things that also fall on our plates as well when we're trying to consider big systems and deployment, whether it's in the live event side of things or in the system and integration side of stuff. Like the graphic up here, for example, is from last summer. Nick Walenda did the high wire walk over Times Square. This was part of our planning phase and communication with the tech managers and the production managers of where they believe needs were for coverage for microphones going back to audio for broadcast, IFBs going to Nick while he's walking the high wire, and even down to communications. So we using FreeSpeak, we had to plot out where antennas would be and consider handoff and all that stuff. Talking about one of the things, bringing it back to the Wisycom track here, hardware for the DAS. Some examples are the Wisycom MAT288, which is a matrix combiner. SPL 2216s, SPL 2206 to 2208 are antenna combined splits, and then you get into the transmission side with CSI 16 and the MPA 4. I think just to kind of get into the hardware side now, this is going back to referencing how we can see it now, how visually we can see this now, what our antenna system is doing, how it's performing, how we can monitor and change it live actively. This is just a screenshot of Wisycom Manager, and all of the all of the devices up top here are MATs. Those are the antenna matrices, and this is from New Year's Eve. They're antenna matrices and current zones that are active. We can see RF power levels coming back, and then the second row, these are all MTKs. 950. These are IFB transmitters, which we're feeding out into MFL, RF over fiber devices, distributing all over Times Square and whatnot. This is just a glimpse of what we can see through the software. This is the RF over fiber side. We can monitor optical levels coming back. We can, if we have a line go down, we can identify that. Or in troubleshooting phase, we can identify dirty glass. This is where we're going to optimize. Use this data that's coming back to optimize our system. Jumping over and kind of moving a little quickly here, just because we'll get to some of the more stories and whatnot. We'll get Jim involved here in a minute, but we'll just get to the hardware part of it. Ryan can show us physically what an MAT looks like. You can see it here on the screen at the moment. And this is one of our preferred devices right now for doing matrix combining of that and receive side. I'm gonna throw it to Dave to just walk through the technical aspects of it.
So Ryan's got kind of a demo rack that we put together for a trip that was supposed to happen in Nashville, a week ago? That was supposed to happen. So obviously didn't happen with the current events here and around the world. But at its core, the MAT288 is a diversity matrix antenna combiner. So it's switchable through several different modes. And on the slide that's up right now, you can see some of the color coding on the back panel. It's kind of the blue row, the green row, and then there's also some marker rings around each of the B and C inputs on the back. Most commonly, we're using it in 8-to-1 or 8-to-4 mode, which would be 8 zone in. So we have both an A and B antenna input per zone to diversity outs. In 8-to-1 configuration, you're able to have, -24 to +7 gain control on each port. So that really helps for tuning out sources of noise, especially when you're outside in the city or trying to do concert or maybe arena work. That they can get a little hairy with people congregating, jumping on two ways right underneath a receive antennas, and really cause some trouble. Where this, you could instantly pop that off. If it's not a zone you need right then in the production, you can always just turn stuff off to reduce your noise floor. But we also have control of gain over each port. Now, in some of the GUI pictures that Josh was showing a minute ago, it shows that we put these on a lot of our remote sites. That way we're able to just sit in the truck and we know, hey, this antenna is picking up a lot of noise, or oftentimes what would happen to us is an E&G crew would come and light up a truck right near one of our antenna farms. And we're able to kind of do a lot more load balancing from the truck instead of frantically running down Broadway, trying to make it 4 blocks through a bunch of people. We can just see what's going on. We have a lot of insight, and it allows us to make a lot more intelligent decisions, but it also saves your feet. You know, a lot of these shows, they're not golf cart shows, and we're putting in the miles trucking back and forth. So some of this did come out of laziness, but we also just happen to have a wealth of this gear that we're able to build our shows out of. Now, I mean, Josh used the word preferred. I don't do shows without MATs. That's the short of it these days. I find that having it there, it avoids some of those conversations you might need to have with the tech manager, or even an A1 if he's getting pressure from EPs or whoever about getting extra coverage, getting that extra zone, getting that shot that they want. Instead of it being an ordeal, it's just as simple as, okay, let's pull some cable over there. Let's get some cable down to the MAT. We can get this set up in a matter of minutes. Everybody's happy, the show goes smoother. You're not doing changes, you're not repatching audio. Hello, Cat. And to redundant receivers, all it is just dialing your new zone. One thing we've been using obviously a lot more, since a lot of our shows are built around Sure's Axiom Digital system, is the MAT can be put into a 4x2x2 mode, which that is what allows us to do essentially a diversity combine, or excuse me, a quadversity combine. And that's detailed a little bit by those rings we were talking about on the rear panel around the connectors. So we can see the yellow set of diversity ends would come out of the yellow outs. The red set would come out of the red outs. So that's a really simple way to get a 4-zone quadversity antenna matrix going. And as some of you have used the quadversity out on the streets, it's 4-zone quadversity is a pretty sizable show. That's a pretty large scale amount of coverage. So it's really become a Swiss Army knife for us. We've used it for a lot of applications, even well outside mics. Looking at the spec sheet, you guys can see it's definitely a wideband box, all the way down to 150. So we've even had applications where we're doing split mode just to do a diversity receive on the first 4 channels, or excuse me, the first 4 zone inputs, while the second 4 we do VHF receive, doing that for rad wireless comms and some of the other applications that are out there for it. And the sky's really the limit. I mean, at that range, this box doesn't care what's coming through it. It is completely open to whatever technologies you're hooking up on the other side. So whether that's radios, mics, anything you want to use it for, it becomes a pretty serious tool for us. Was that enough of a dive for you, Josh?
I think it was. It's an image of an example. Jim, do you want to add some stuff just about the theory and approach and on the receive side of DAS? No. Muted?
You might be muted.
I'm sorry, I muted myself. Yeah, I think you guys covered most of the nuts and bolts. If I could add anything, I guess I'd just try to create context, which is the idea that we have a full ecosystem from all the way from the antenna, and to paint some pictures here, like if we use Times Square where the Walinda show was, we built DMARC racks, and there was a DMARC rack at, say, about every city block or so. And each one of those DMARCs would have one of these MAT288s, and it would also have an MFL RFoF fiber system. So you'd have maybe 4 antennas servicing, say, the 48th Street block or 46th Street block or whatever it was, and 4 or 6 antennas maybe servicing a stage or certain areas, production areas. Maybe sometimes there's there's like a green room or some sort of tucked away area where they want to get maybe, or a stand up and interview area. And then we're also at the same kind of, there's also a wire going 100 feet above the street, and we kind of want to serve both masters. So the MAT sort of lets us do that in that particular area by using different antennas to cover those different areas, different zones. And you bring them back to the MAT, that connects to the MFL. So now you convert it to fiber through the MFL, and then the MFL sends it back to a head end where there is another MAT288 collecting several of these MAT288s. So you have this big sort of star topology where now if you add a network layer to that, which is the key part I think about Wisycom and or this particular ecosystem, is that, and this was the part that we really worked on to Dave's point, because of the years of doing this, going out and being an RF guy. A couple of things about doing RF. For one, you don't usually have a lot of people. Usually you're kind of working alone. And so I always found that, if I were doing, the more coverage area that I had working alone, the more sneaker net I was involved in. So the more walking I was doing. And as we started to evolve fiber in general, like using Times Square as an example, if the head end was at 44th Street, and in the early days, if you had to make a change or even kind of get some sense of what was going on locally at 48th Street, the only option might just be to send a utility or somebody that didn't have a lot of RF knowledge to that site and try to radio back some intelligence. And with this, what we're able to do is actually look at those devices and actually control every input to the antenna system. And in a way, because we have software control, you can solo almost that track, if you will, using an audio term. You could theoretically solo back at the head end an individual antenna and find out exactly what's coming in a specific site. So if you had a talent or somebody out walking microphones, you had a utility or an A2 out walking microphones, you can really dial in the level of coverage from each antenna at, say, this 48th Street area. And while you're having your test guy walk around and do their sort of war games, you can really dial it in. And what we're usually looking at, by the way, when on the context of receive here, is we're usually looking at a spectrum analyzer at the output of the final MAT288. And that spectrum analyzer is kind of replicating what the receiver sees in the wireless mic signal chain. And so, I saw a really good webinar this morning on Sennheiser where they talked really a lot about signal and noise and really broke that down. Jonas did that, and we won't get into that here, but the object of this game is obviously your signal to noise, and this gives us ultimate creative control. A lot of times when we approach these, we tend, at least I have for sure, because you almost know with these bigger shows that you don't know always what they're going to do. And so the idea is to just design a grid, an antenna system, play zone defense is the way I sort of look at it. You build this massive grid. Sometimes I'm putting antennas in places that aren't necessarily, people aren't asking for coverage. But then when production comes in the last hour and they say, well, we just changed the rundown, can you cover 45th Street? We can say, yeah, and we just dial it up, we turn it on. Because we've already wired it and we're ready to do a show. We're ready to do whatever we need to do. We have ultimate creative control and flexibility. We're not running out, unplugging things. We're not radioing back, to some guy out there going, hey, plug in another one, plug in another one. You just build these grids and then you sit back and you have it all on a control panel. And this is, again, on the receive side. Transmit's a kind of a different beast, and we'll get into that. But this control layer is something that we've been talking a lot about just at Jetwave. Just the element of the control layer is something new, even in our designs. The idea that we are providing control layer information, networking information, because the MFL, the MAT288 are all networkable devices and IP-based devices. And there's a control that happens between the MFL, between the MAT288, which is the device Dave just talked about, and the endpoints themselves, which we'll get into that with the BFAs and filters and stuff.
Actually,
so,
Jim, if you want to continue on that, Ryan has in his camera exactly that.
Yeah, can you show that slide on with the BFA if when we talk about that? So so this is key in the end, what we call, or I would call an endpoint, which is usually an antenna. In the bottom of the screen, you see it's an inline version of the same thing that Ryan is showing on his screen, which is this. It's in theory we kind of call it a booster in our industry typically, but what's unique about this is that this booster and a lot of manufacturers make this kind of thing, but what's unique about this is that you can control it, and also it's multi-bands. There's a lot of options in this. Typically, the more legacy stuff that we saw in the past would be you had maybe one or two filter presets, and then there was a specific gain, and that was sort of the baseline. Well, what this does is, and you can see in the graphic that's blown up, is that there's actually 3 different tunable filter options, and one of them is a tunable 40 meg window from I think the tuning window is 470. It says it right there, right? 410 all the way up to 730. So that's a completely sweepable, tunable thing that you can just dial that up. So if you have all your front end of your RF system is connected through these things, you can have a filter window and completely control the entire thing. It's high end. There's no question that it's not the cheapest way to do this. I can tell you just from experience and sort of speaking out of my gut here is that, a lot of times you look at stuff like this and you go, God dang, that's so expensive. And our good friend Dave Bellamy said to me once, he said, well, my job isn't to make it the cheapest, my job is to make it the best. And so when I, sometimes when we look at what we're doing with RF systems, it's expensive to do this because these things are not cheap. They're, I don't know, $500 or $600 a piece, $700 a piece or something. And to put one at every antenna is expensive. But the stakes in today's production world at the level that we're playing are pretty high. To take an RF hit for us is a pretty big deal, as probably most of the people on this call know. And so anything that we can do to engineer the most robust and agile system is what in my mind, is what we should be doing. And then we kind of deal with the cost. But that's what this is. This is the kind of the premium front end for an RF system, because you get tunable options. So you got a tunable 40 meg window, then you've got a fixed wideband option, which kind of makes it a little bit more vanilla. And then there's some preset bandpass filters, which we might get into a little bit later, because when we talked about DAS in the bigger picture, usually deployment of DAS systems, well, it always does, it involves some sort of band planning and this is not a beginner level concept where you sort of say, I want to put all my, let's say, in-ear monitor transmit frequencies in this window. There's a lot of different theory on how to do that. But the basic idea is that we're going to say, hey, we're going to take this chunk of spectrum and use it for this, like I always think of it like a 2-lane or 4-lane highway. We're going to send all this stuff down this road, and then all the receive stuff we're going to take down this road. And that gives us the ability to push and pull in either direction without impacting. So you're building infrastructure. That's what this is all about. Band planning, DAS systems are all about infrastructure at an enterprise level. Not this isn't for the faint of heart, right? And this webinar is not really intended for the new guy necessarily. This is what we do, and that's what we're trying to share, our experience around what we do in the deep end of production. So bandpass filters at the front end are imperative. They're absolute necessity. I've had a lot of people, even on panels, weigh in and say, well, the only way to do a fixed to do a front end is by putting a fixed filter, et cetera, But I like the agility because I never know, like if you're going from city to city to city, every city you get in is different. So if your front end is tunable, then you make the adjustment, you're up and running. It's just like a lighting system or an audio system. You tune it, you turn it on, or you turn it on, you tune it, and you commission the show, and you're up and running. Then you sit back and do your show. The last piece, as I just mentioned, this high pass, low pass presets is the other part of this. So there's all this tunable stuff. The other thing about this, the biggest thing about this is that these are controllable parameters by way of the MAT288 on the front panel and through the manager software. So you can talk to the MAT288 over the network. a remote site. So if I'm at 44th Street, I can talk through the network. Usually the network's over media converters through fiber to, let's say I'm using the example of the 48th Street site. We're talking to the MAT288, which is controlling these specific antennas and filters. And also there's obviously in this block diagram, you see an LNA, or basically an amplifier, which has an extreme amount of gain. And kids, I don't know why they have plus 27. I don't think any of us really know, but plus 27 available there. I guess if you're going to drive 2,000 feet of coax, maybe you need the plus 27. But it does plus 27 down to minus 12. And one thing I think everybody on this panel would agree with is that probably the 0 to minus 12 feature is more important to us than the plus 27, because more often than not, we're actually trying to minimize the effect of a zone and control its dynamic range, or its effective, like, kind of radiated area of coverage. That's the whole art of distributed implementation, is to really be able to control how much energy is coming in where. And if we always look at it like Josh had the slide with the circles, we use that circle as kind of our reference. We'll draw those circles on a map and say, okay, we want this to happen in this circle, this to happen in this circle. And then when we build the system, that's basically what we do. We paint it. We just paint the system in. Incredible amount of flexibility. It's very advanced. I mean, there's just, this is thinking way, this is just, it's just really advanced. You know, there's not a lot of, there's not a ton of, I don't want to undersell this, but there's not, not every show needs all this stuff, but to have tunable front end and to have an MAT288 on most shows in today's world is, I think, would just make life completely, it just makes it a lot simpler. Like none of us for sure would do a show without these tools at this point. It would be a huge step backward for us, for me, to not have these tools. We developed these because of the problems that we have around agility. Agility is the name of the game. It's being able to respond like that in a situation when something happens and you go, oh yeah, okay, I can make a change. Old school, it's, oh, I got to run out there, I got to run 4 blocks, unplug a bunch of stuff, plug something else in, that kind of thing. And this, it's none of that. It's not like that anymore. Now you just get on the network and you talk to something and you make a change. You make a dynamic range change or a filter change or add some gain. Maybe take gain out of one zone, add more in another. A lot of that kind of stuff. So.
Jim, to kind of jump in behind you and touch on something you just said is about taking gain out, adding gain to different zones. These systems do allow you to take a much more active role in your show. You have a lot more tools in the toolbox while in show, where often with a lot of the kind of more fixed DAS systems or systems, you know, where you're swapping out pads and things like that to get things going right. That agility allows you to really be on your feet. You know, you think of many shows where we're looking at we have every zone in the system up and we're just not seeing the signal to noise we want. And then we can kind of target the things that are maybe bringing our SNR down, pump those zones off while we don't need them, only bring them on for that hit that we know is going to be in that spot. As opposed to just kind of sitting there and staring at the RF bars in the front of your rack and hoping is a big kind of change in this workflow for sure. There's a few questions that came up that I kind of wanted to touch on while I was following you up. Brad, you've asked 2 questions, one about the MFL, which we'll probably get to a little bit later, about the different levels you would see on the fiber side. I'm going to make an assumption about it, and I'll talk about it later when we get to the MFL. About optical levels and seeing optical level fluctuating and how to troubleshoot that and some of the tools that are built in there. Another thing Brad was asking about is the BFA, LFA, any of the active antenna components. Can he control them with the SPL 2208? And that is a feature of those boxes. The 2208 and 2216 are essentially the Wizy products that we use most often to do diversity kind of distribution in a rack or antenna splitter, so to speak. And the 2208 2216 both allow full control of any of these endpoints. They just don't have a jog wheel and an LCD on the front. So you do use the software for that.
Hey, Dave, can I just throw in the 22.8, 2216 are multi-couplers with 2 inputs instead of a single one. So like most traditional multi-couplers, that's what it's intended to do. They're just
and a lot of shows, that's all you need. You need to cover the deck, and you need to cover green rooms or A2 World and get your mic table covered. Steve, another question you asked, is the software dedicated? Yes, it is standalone software, and this is something we've been doing a lot of field testing on. And it's been around for a few generations, but the software we're discussing is called Wisycom Manager. And this is more akin to your wireless workbenches, WSM, those types of systems, LECnet, any of the monitoring systems, but it doesn't just stop at mics. It controls a lot of their platform. So that's their IM transmitter, these antenna matrices, the splitters we're talking about, as well as the active antenna pieces in there. And kind of touching on the same thing, Jason Glass, you're asking about integrating multiple remote head-ins. I'm assuming that would mean multiple instances of the software here. So I'm going to run on that. If I'm wrong, just correct me with another question, and we'll get back on it. That is something we've actually been field testing a lot. That's a new feature that's in the kind of bleeding edge beta we are working with. So Wisycom has released a few beta drivers that go with the software to allow remote control and also permissions-based remote control. So you can turn on remote access for other users in the system, but you can kind of say, well, you're the A2, I don't really trust you having complete access to the rest of the DAS, the MFL, the MATs and stuff, but you can look at it in a read-only sense. If I'm off on your question, just go ahead and shoot another question in there and we'll get back to it. And Steve, to answer your question, right now it is Windows only. A lot of us at Jetwave are Mac users, and we just run it in a VM with no issues, and it doesn't mind the VM at all. Back to you guys. I just kind of wanted to get caught up there a little bit.
I was going to say one thing to add to you spoke of troubleshooting zones and coverage and trying to find, rogue carriers or whatnot with the MAT. Another bonus for it in the world of digital accent is you can identify while you're setting up if you have not so optimum antenna placement, overlap and whatnot. If you have to do a show with multi-zone diversity, which is our least favorite way to use something that was meant to be so much better. Quadversity is the only way to use that. But you can identify poor antenna overlap and coverage. If you have 2 zones activated on that MAT there, you can see your QoS tank and start to move rapidly. If you disable one zone, you will actually see that QoS skyrocket to full and hold steady. It's an indicator that these 2 zones are negatively impacting each other. Just another cool use of the tool and how it can help you optimize Axient Digital.
Can I chime in?
Yeah.
Are you done, Josh?
No, yeah, you go ahead.
Okay. I was going to talk about a use case with digital Axient, and we're Jetwave qualify this. Jetwave's a sure dealer. We have a gazillion channels of it in our rental department, and we love it. We use it, and it's popular and it's good stuff. So that's one of the systems that most of us are putting on these DAS systems, on DAS in general. And this is just an interesting observation about introducing this kind of thing to a production environment. There's sort of a few business case scenarios. One is there may not be RF expertise present on the site, right? So a lot of times shows don't have people that understand this stuff. And so they just kind of want to set it up and leave it alone. And so we had an interesting situation where I'll redact this. So it was a studio where there were about, let's say, 16 existing zones or something, and they were all on all the time. And we were using digital Axient in this case. And what we found, and it was an upgrade from an analog system. So the antenna system that used to support the digital, I'm sorry, the antenna system that used to support the analog wireless mics, which behaved a certain way. When we put the digital Axient system on, it started, the results were very different. And so what we quickly was able to kind of isolate and then fix, if you will, was that if we reduce the sensitivity of the overlap of the zones, that we actually improve the performance of the system, because with the digital wireless mics, if you have too many sources, like in theory, and if you guys stop me if this is getting too deep, especially my three guys or Pete or anybody, just stop me. But with digital wireless mics, and this is, I think everybody on this, I'm going to guess that everybody on this webinar is using digital Axient mics often enough, or if you haven't, you will. They behave differently, and so they're clock based because they're digital. So if you have, let's say, 3 different receive antennas, which is kind of what a DAS system is it takes and sums a whole bunch of antennas. Ideally, you don't want to be summing a whole lot of stuff. You want a certain amount of isolation between zones. It's not the idea. It's kind of like having a bunch of microphones on a stage. You don't want everybody speaking into everybody else's mic, and DAS is similar in that you want to kind of have isolation between the zones, and that becomes super critical with digital wireless mics. So what we found is by reducing the sensitivity of each zone, ultimately the short version is we reduce the sensitivity of each zone so that there wasn't a lot of crosstalk from zone to zone to zone to zone, which essentially kind of equals noise to the system. Like digital, it starts to see that as noise. And what we found is by having this control, and it's real-time control, by able to just sort of dial it in and commission the system, we were able to walk around this facility, desensitize or turn down each zone to only really get what it needed. And then, and maybe we moved a little bit of antenna around a little bit to make some adjustments, but very little else was done. And we improved the environment, tenfold. It was, the customer was very happy with the results. So, so here's the interesting part about this business case is going back to the expertise. Clients don't always, so there was a big concern about, to Josh's point, and Dave's point. So who's going to own the button to change the zones on and off, right? Because audio doesn't necessarily want, in a traditional TV environment, maybe the audio guys don't necessarily want responsibility for an antenna system. So it gets a little gray. And then also you find that the maintenance engineering team might not be able to be present during the show. They might not have the bandwidth, the budget or whatever, just have somebody sitting there saying, well, when you're not using that 16th zone on the next floor, which they use once a year, just turn it off, right? This is the simple version of all this is, if you're not using the zone, especially with digital, with Axient, if you can help it, just turn it off, which goes back to what Dave was saying. This is a little bit more dynamic. Now, I just want to say this, because this is about, in some ways, I found that this is about the business of wireless as well as the technology of wireless. The idea that someone has to own this button and introducing this concept to the team at large. I just lost my train of thought. Well, what we found was this ownership. They said, well, we don't want to have to be changing the wireless mics. And here, this is an important point. Like, this is a kind of a new thing. Wireless DAS, wireless infrastructure being, you turning stuff on, turn stuff off, and they're saying, well, why do we need to do that? Well, wireless is different now. The spectrum is completely different than it was 10 years ago when anybody could do this, especially at the deep end when you're using, like Josh was saying, 100 channels or something. What my argument is with this, and our thought is with this, is that all the elements in a production are are dynamic. When you set up a show, all the audio gets placed, the microphones get dialed in just the right gain, all the lighting gets placed just the right gain. But in the old way of looking at things, you just set up a couple of antennas and it stays the same and nothing changes, right? Well, my theory on this is that I think the RF environment needs to be just as agile as the lighting environment and as the audio environment. And that's sort of the idea around building these systems, is that, yeah, it adds a level of ownership and it adds like maybe some expertise. For the most part, we're able to set these and forget them. And then just the training to the end user base is something like this. Listen, if you're not using that zone, turn it off. That's it. You don't need to be a rocket scientist. Just if you're not using that zone that's like, 1,000 feet away, 2 floors up, it's just, and so I know it's a little bit of a rant, but it's complicated when you get into situations where, there's not a lot of expertise and the ownership is sort of, people want to push it off. So there's a little bit of a sell here. And when you're working with, as an install company, or you're working with other end users, you're not, like, we're not necessarily the end user or the provider. We're not on site with it. Those are just some of the, I find some of the more interesting aspects of this. But here's my point, is I think that distributed antenna systems are a dynamic production element, just as is audio. RF is a dynamic production element, just as is audio and lighting. That's my, whether we want it to be or not. Now, right? I mean, yeah. I think everybody on our panel would agree with that. It's like, you don't set this and forget it anymore. It's not completely like that. I mean, in studios, you can get it dialed in, but these big, large remotes, award shows, these things where there's just so many different moving elements, you can't just come in and kind of do the same thing every year you did last. You put up 2 paddles on the side of the stage and that's it. It's not like that anymore. Anyway, it was kind of a rant, but I think we're in the business of wireless as much as we're in the technology of wireless, and those are some of the challenges around resources, which are people. Like, we don't always have the people, and again, the argument is that this is a dynamic production element, and that's where this technology comes in. So anyway, I could keep going. So,
and then we had a question from Stan. There are many levels of production RF needs. Can you outline a circumstance of production when you reach the point where you should be considering implementing these applications? Simple answer is the RF guy answer. It depends.
yeah.
I mean, it could be always, or it could be never. I mean, I think it's, to keep it simple, think of just go refer to the MAT 288 that we were showing you guys. That one piece could be the thing that you always consider. Going back to how Dave referenced, you're always going to cover the stage. Think about your basic corporate shows, your corporate industrial shows or music shows. You always have to cover the stage where these elements are happening. And then more often than not, we have to cover a thrust. We have to cover the front of house to a B stage, or cover backstage.
And that's my cutoff, is there another area of coverage? And whenever I start thinking if I need some 2-way splits or anything, no, I need an MAT, period. When you get those other kind of elements thrown at you, whether, like Josh was saying, it is a thrust, it is somewhere else, then we're at least going to be looking at some of those solutions. Does it need to be the MAT? Could it just be a 2208? Yeah, absolutely. And that's going to be a lot of corporate shows and things like that, where you need to cover your main stage, but then you need to cover where talent's getting mic'd for line checks, things like that. That could be just a very simple way to get what you need out of the distribution gear there. Sorry to cut you off, Josh.
Here's an example. Here's a couple things I want to say about this. One, I think the real barometer for whether or not you need this is how much stress you have over whether or not you're getting coverage.
Right.
If you're stressed out, then you probably should be looking at other ways of doing it, because at some point along the way, after I don't know how many shows, I would stress about every show I've ever done up until I finished. It would be a lot of stress, and at some point in the last 10 years, I was on my way to a show, and I was sort of in the same level of stress, and I had this thought, which is, you've never gotten into a situation that you haven't been able to get out of, and you have the tools you need. And because we had developed so much technology that with like an MAT-288, there's nothing that just a couple of antennas couldn't solve, right? It's just, well, let's put up some more antennas somewhere if they're throwing something at you, that kind of thing. Production says, oh, well, tonight we want to send the guy, he's going to come in through the loading dock, and we're going to do a live, we want to record this live, but we want him on his mic. Then, you can put some paddles on a stand and sort of set it up in the VOM or whatever it is. You have flexibility. I think stress is a great barometer for whether or not, if you're going in and you're turning your mics on and you're kicking back and you're having coffee and everything's chill, maybe you don't need it, But I wasn't, for many years I wasn't in that situation. I was sort of chasing my tail, trying to figure out ways to cover so much area. And I got to tell you, I don't know about you guys, but I don't have a stick mic here, but I would have guys, I'll use my bottle of water. I have guys that would take the microphone, and as you guys know, most of it on a handheld microphone, the antenna is at the bottom. And I would have the A2s that before the show walking around, holding the antenna up to their body like this and trying to cover it up and walking all around and going test, 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 test. And they'd go like to the weirdest areas, and they'd come back and say, well, it didn't work over between those two LED walls. I heard a hit, right? Or I heard a dropout. And then that's my problem. Now it's my problem because I'm the RF guy. And so the level of the expectation was unbelievable. So one of the things I started to do is I would put antennas up under the stages, right under home base, like for an award show where there's a monitor wall end to end. I'd have antennas like 3 feet from the guy, right underneath him.
Jim, a very relevant comment just popped up in the questions from KP, your friend and mine, Kevin Parrish, saying about people need to re-examine what they expect, what you were just talking about, for coverage. Antennas closer to the TX will become a standard operating procedure for all of us.
Yeah, that's right. Signal and noise, right? It's signal and noise. I think that DAS is about it's controlling the signal and noise, soup to nuts. Instead of being sort of a victim to it, you are in control of it. That's what DAS is about. It's like, no, I'm going to put this here because I know exactly what's going to happen. And it's predictable. That's why we do this, because new RF guys don't know what they're doing. And so it's unpredictable. We don't know what's going to happen. Well, we know what's going to happen, right? We've done this so many times. We know what's going to happen. And that's what these tools are about. It's like, well, we know how to get results. And because that's what people pay us to know, right? That's what they pay us for, our expertise. So anyway, I'm ranting a little bit.
All right, so let's move over to the transmit side of things. Because there's a lot of this. It's the same thing in reverse, right? We're pushing it the other direction.
Yeah.
Sure.
And that also means we're at the second hour of happy hour.
Yeah.
Here we go. Next one.
I'm going to take
Yeah.
Cool.
System design considerations. They're a lot like the other way, only now we're worrying about gain structure a lot more because we're not dealing with free space loss and other things that are making the signal be a lot less by the time it hits our antenna. So gain structure is a huge thing. This is where RF power comes into play. When to use it and when not to use it. Where does the system loss start? Antenna placement, physical setup of the venue, just like talking on the receive side. Receiver location of use. Where's that belt pack gonna operate throughout the space? And do I need to have multiple areas of coverage? And that's where we're going to get into using splitters. And if you're going to use splitters, we're going to have to use some kind of makeup game to deal with the loss inherent in the splits. RF transmit technology. So one of the things that we use a lot on the in-ear IFB side of things is MTK 952 from Wisycom. Also out there is the Shure PSM 1000, which a lot of people are familiar with.
Can't avoid it.
Can't avoid it. It's been the standard for many years and works great.
Yep.
Transmit combiner side, all the major manufacturers have their version of the combiner as well. You got Shure P821, it's an 8-to-1 combiner. Sennheiser AC3200, also an 8-to-1. And then you got the Wisycom CSI-16T, which is a couple things disguised in one package. It's got some party tricks up its sleeve. It can be a 16-to-1, a 2x8-to-1, 4x4x4, and it's a smart wideband combiner. It has some elements within it that allows for a communication circuit back to the transmitter, so the transmitter can make up gain for the split. This is a passive combiner. Going back to that question of where's the first point of loss in your system? It's at the BNC connector of your transmitter. The antenna options, we're not going to dive too deep into antennas and what those are, but you got to consider your antenna options for the space that you're trying to cover, whether you want long throw, helical, short, medium throw, A5000 CP, or a fractal antenna, or do you need an omnidirectional to cover the space? Let's go, sorry. Do Dave or Ryan, do you want to go over the MTK that's in your rack there and kind of show it a little bit?
Yeah, it's kind of hard to get into the back of it. Let me switch camera.
Yeah. Do you want an NPR 50 to go with that, Ryan?
Sure.
Here.
Oh, thank you. It's right here.
You're welcome.
We've been practicing that all week. Okay. Yeah. So we got the MTK 950 right here. It has master slave mode on this unit. So what you can do with master slave mode is if you set the unit up as the master, you'll have, and it has the option of master slave, you'll have a BNC port on the back that will output 1 milliwatt to go into a MTK 952 that's set up in slave mode. And what that basically does is uses the transmit amplifier to rebroadcast the transmission of the master MTK 952. And this can be done either over fiber or over coax. And Dave, do you kind of want to dive into RF over fiber now, kind of talking about the transmission side of RF or?
Yeah, we can. Before we jump onto that, we should talk a little bit more about the 952 and some of the other options there and why we never shut up about it and always bring it on all our shows. So the 952 that Ryan was talking about available with the master slave mode is often accompanied with an option for a 2-watt power amplifier inside. So the actual output stage of the unit is capable of 2 watts. The reason for that is the CSI-16 that Josh mentions. Josh, give me a little laser pointer on it up there in that this picture there. That's that 16-to-1 or switchable to 8-to-1 by 2 or 4-to-1 by 4. It's not actually an active combiner. At its core, it's just a series of 2-to-1 combiners staged together that are switchable with the toggle switch on the front. What's different about it though is the Wisycom transmitters are able to sense what setting that combiner is on and actually ramp their output power up past what would be a legal limit outbound to the connector, but it knows it's hooked up to a Wisy combiner. So it's actually able to drive our path loss there going through the combiner. The kind of different stages in there at let's see, that's going to be what, 6, 9, and 12 dB of loss, depending on your setting. It's able to overcome that internally. All of this was developed mainly out of demands from the Japanese market. Their actual emission limit is 10 milliwatt. So we kind of needed to come up with some creative options for getting over that. And actually, I think this particular thumb that Josh grabbed for the presentation here is that example, in that all of these units are hitting the front end of the of the combiner here at an 8-to-1 at 80 mil. So our outbound is still in the legal limit, but now we've overcome all that path loss. And what we found with that, including some of the inherent isolation, port-to-port isolation that you see in that switched combining style built into the CSI 16, is just unbelievably clean transmit power. And that kind of has become a very common ingredient in our recipes that we're putting on shows. The CSI 16, we don't use it a lot with other gear. You can, we find, like, unless you're cramming Electro T1s into it, it's often hard to have enough power to overcome some of that loss in there. And it's a big part of our workflow, both in our fiber systems and in a standalone system. It's pretty common for us in an IFB rack. Worth mentioning too here that the reason we use a lot of these technologies with reckless abandon is the 952 doesn't really care what receiver you're going to. It has a lot of other companion schemes in there. So if the talent demands a certain type of receiver, I only use a P10R, P9R. We're able to transmit in Shure mode, in Sennheiser mode, and give the end user what they want, but we're able to build a DAS robust enough. So like Jim said, I'm not getting yelled at. I'm not stressed. I'm just sitting there making sure the thing's humming, and I'm running at a much smoother level. And that's along the same lines of a story that Josh and I were on a show, and somebody had mentioned, like, oh, these guys just hanging out, huh? And the TD said, those two guys are the ones you want just hanging out. If they're panicking, the show is going to shit. It's going bad. But it's as far as transmit goes in this workflow, I haven't come across a lot of stuff that can even hold a candle to it for us. So if we kind of covered enough there, I know we had a few more things we wanted to touch on the transmit side, but I'm happy to roll over now that we're in hour 2, kind of into MFLs and RF over fiber.
There was one question, Dave, does a combiner have isolators? What is ISO-DB?
So that I can't remember off the top of my head whether it has an isolator per input. But what you're going to see is you're going to get slight, as I was describing, and actually I think it's a diagram on the front panel or somewhere on the unit, but it's a whole bunch of 1x2s going into each other. So you're going to get a lot of isolation just port to port in a 1x2, not a lot, but maybe 20 dB. But now the adjacent ports that you're going into, you're getting that 20 dB, this 20 dB, and this 20 dB. So your port to port does get pretty high. I'll go ahead and pull up a spec sheet to find that out for you, Pete. Jump in there.
While you, I was going to say, while you pull it up, the other question from Nicholas, what about Sennheiser 2050 IEM on the CSI 16T? Absolutely. Yeah, we've done this. We have a couple tours out there that started and or still use PSM 1000s or Sennheisers. Just be mindful that if you're in 16x1 mode, it's a passive combiner, so there is a loss that you're going to have to make up. And the 2050 has RF gain in there that you can use for that purpose. It'd be probably more ideal to keep it in the 2x8x1 mode for that. But it's the intelligent part of it is only going to work with the Wisycom MTK 952 device. It's not going to work with Sennheiser or Shure. But yes, it does work. It's going to pass that RF.
I just want to chime in about the concept of transmit. It's another thing I'm kind of plugging the Sennheiser webinar I saw this morning, but the question, it was the first question I think that came up, and they said, are we going to talk about transmit? And the answer was, well, no, because it's such a big topic. Combining, and I think we can talk about it for a minute, but combining RF transmit there's a kind of a couple of ways to look at it in the context of what we do. One is if you're just doing a single combiner, which is most of us are familiar with PA21s or the AC3200s, or which now the Wisycom CSI16, which is passive. Jetwave's actually sold the box sale to customers that we didn't qualify it properly, and so this CSI16 ended up in the hands of someone who was just using it with I think well not an MTK 952, and so because it has even an 8-to-1, it has a 9 dB insertion loss. In my opinion anyway, not ideal. These guys were saying people do it, they do it. I personally, I don't think it's ideal to use a CSI 16 combiner because it's passive for that kind of thing, though you can do it. The MTK 952, like Dave was saying, is designed to compensate for that insertion loss, and this is where it can get into the deep end. With transmit distribution, there's a lot of lift that has to happen to get transmit energy out to multiple zones. You can't take a plus 17 dBm and then insert a bunch of lossy stuff. So maybe let's say an 8-way combiner, which would be let's say 9 dB loss, and then a 4-way combiner for splitting, and then that's another 7 dB. So now you've got 16 dB of loss for your IFB transmit. And this is all about link budget. So if that's just a lot of loss, it's just unacceptable. So you have to, when you start to do this combining and splitting, you have to come up with methods for amplifying this that are non-destructive. And there's so many things that can happen when you get into amplifying. And before I get too deep into this, I'll just poll the rest of the guys to see, how much of this transmit stuff we want to talk about in terms of just amplifiers and when to use them, or do you use them? Are they legal?
I think it's going to be.
This is a conundrum. There isn't one off-the-shelf amplifier that I'm aware of, which is the MPA4, which happens to be a Wisycom product, relatively new, where it will replicate 4 carriers on a single input, and you will get, I think, the 50 milliwatt output, and it's all FCC, type accepted stuff. And that's the key here. Is a lot of times when you get into RF over fiber and just transmit combining, and you're not using, let's say, the more conventional off-the-shelf technology, you're starting to go off the reservation in terms of how you can do it and whether or not you're compliant. And if you start getting into that area, then you really want to know what you're doing. And so you can get yourself and your comrades on site into a lot of trouble if you start messing around with transmit amplifiers. I've seen some live touring companies delve into some of that DIY stuff, and it creates a lot of mess in the spectrum. And we're going to show some slides, actually, I think, about what it looks like, kind of what not to do. And this is what happens is people, that when you start getting into this and you start experimenting with it, especially with amplifiers, it's really easy to create adverse results. It's really, and I've always felt in the R&D lane of RF, first, do no harm. That was sort of, and I think we always have to bring that into transmit combining and the art of transmit combining and the science of it. It's always about do no harm. I'm going to ramble a little bit, but when I started delving into this stuff, I didn't know a lot about engineering theory, to be honest with you. And what I realized is that if I took a spectrum analyzer and just a body pack transmitter and I held up the transmitter, I'd look at the spectrum analyzer and see what I got. And if I could start messing around with receive distribution systems, so long as when I was done, it looked like what I had when I started. And that was sort of my baseline. And if I introduced a whole lot of noise, then I knew that wasn't good. If I introduced a whole lot of harmonic problems, intermod, then that wasn't good. And so that became kind of the baseline. And I learned in that process, do no harm. So I think this is the biggest gray area of RF distribution. I think Jetwave probably knows more about it Well, I think they do. I mean, we just have so many different ways of approaching this and tools. But I guess we'll get into it more. Sorry if I ranted on there, you guys.
No, I think
Touching on
that's-
a few questions before we jump on. Nat was asking, where does the name Wisycom come from? It's actually a concatenation of wireless systems for communication. And they just smushed them together. And then John Christie had asked about CSI 16 being compatible with Electro Duet M2, which are fussy about the combiners they use. They don't really have enough output power to be used in a lot of configurations with it. It could be done, but it's not going to be the good box for it. Personal experiences say they like isolators to be the first thing they hit if you're doing anything that doesn't involve just slapping an antenna on it. So that, I hope that kind of answers your question. Probably not the best box for that IFB transmitter.
Yeah, again, the CSI 16 is really designed to work with the MTK 952 because of the power compensation. And the whole theory behind that was they could get greater linearity and ultimately better signal to noise by not introducing combining amplifiers and getting all that gain in that first amplifier, because 2 watts is a lot of juice. So if you can get the 2 watts, a super linear carrier, really high signal to noise into the distribution system, and it can sustain the loss and have enough when you get out, then it's a good solution. And that was their theory, as opposed to, let's say, you know, the way that we've approached it here in the US, which is we had, I mean, the first ones I remember were like the PA821 initially, a long time ago. It's kind of was my go-to for a long time, where it's a unity, its intent was it was a unity gain box. Even PWS has some stuff. The intent is it's somewhat of a unity gain box. The TX8, the RAD TX8, that's actually pretty cool because you can take a you know, a 20 milliwatt transmitter and put it up to a 1/4 watt. So that was actually kind of a little bit of a game changer in the off the shelf transmit combined. But theoretically, those amplifier stages are a potential noise, you know, signal to noise or intermod producing stage. And so Wisycom's theory was, well, we're going to put just this big badass amplifier with ultimate linearity at the beginning, and then you won't need to insert any other noise producing or intermod producing devices downstream. And we're going to design the whole ecosystem for distribution, which is a little bit more about how Jetwave looks at it. I think is that we are more about a holistic view of the spectrum. We don't look at transmitters, we don't look at receivers specifically, we look at the whole, we look at the results, I think. And that's where these ecosystems, they are systems, as opposed to, well, I have this box and can I make it work with this box and this. So anyway, there you go.
Let's move over to that last topic of RF over fiber. What is this voodoo magic that's starting to creep into our industry here? It helps to extend the range of wireless performance to a centralized equipment, so the DAS that we've been talking about. It can have full duplex capability, allowing both transmit and receive. The device that we will talk about specifically does do that, and it is customizable in how it is set up. It helps to allow for a single interface point for audio. Conventional approaches would require additional power line amps, additional mix inputs, multiple receivers, transmitters, synchronized activation and deactivation of redundant IFB transmitters, etc. All kinds of things that, when you break it down, is it worth the time, the manpower, and the money to not use RF over fiber in a lot of situations? The return on investment has to be considered. Now, let's pass it over to Jim to give us a history of how he came to be, and he's had a lot of involvement in the Wisycom MFL product and how it came to be, why it's a thing in our industry.
Yeah, it makes me think that, you know, the first time I saw RF over fiber, I want to throw a little kind of a shout out in memory to my friend Jim Malone, who passed away last year, I think it was, who introduced me to RF over fiber back in about 95 with some friends that I know that are on this call. Actually, we were actually splicing fiber in the field in golf, and we were doing NBC golf, and this is with Total RF, and that was the first time I ever saw it. And we were doing RF receive, and we would have fiber all over these golf courses, and it was a real carnival. I can tell you, just all these people, and people who do golf know that, you know, it's a circus anyway to do golf, and, you know, deploying fiber every week and all that stuff. So that's when I was exposed to it for the first time, and I learned about how to kind of the basic concepts of that. And when I later went back to work at Systems Wireless several years later, and we were presented with a problem. It was the building is the museum, and I was at Bextel, who owned, and that's what this picture is from. And they the museum wanted to do RF, or they wanted to do RF all over this building, a 600,000 square foot building. And I had been doing golf for almost 7 or 8 years, like that, exclusively. And I was walking around the building, and I asked the guy, you know, where do you want coverage? And he said, well, everywhere, if we can, for our BTR 800s. And then he said, also, and by the way, we're really late in the construction phase, and so we can't pull coax. Can you do this over fiber? And so immediately I was thinking about all the RF receive that we did. And I thought, well, yeah. And I started to look at it, and you guys have heard me say this 100 times, but I was looking around the building, and I'm thinking, you know, 1T, 2T, 3 green, 4. It just started to look like a golf course. And so I started to replicate that in the building. And where the hurdle was the transmit, and that was something we talked about a little while ago, was how do you deal with multiple carrier transmit over fiber? And I spent a lot of time, you know, just working through that problem. And so this system that you see here was the first system that we had built at that time. We got to do a lot of good work. You know, I had a really cool boss. He was very supportive at Bextel, to kind of help me do this. And we had to really, there's a lot of, you know, bigger companies, you have to do a lot of justification, but we were able to kind of get it to happen. And what was driving this were some of the bigger shows, like at Disney, Christmas Parade, and shows like that, where they wanted a lot of coverage. And I was surprised that, you know, I was thinking wireless mics and all that, but what this became, RF over fiber started to become for us anyway, was I wanted a system that was agnostic, so it could support BTR 800s with transmit windows that were, say, let's say 500 to say 570-ish, or 5 to 600, and a receive window that was like 600 to 700 at the time. So that, we were talking about band planning earlier, and that BTR 800 kind of dictated a little bit about how these things came about. And there's a lot of two-way radio theory about inbound, outbound, and isolation and filters and all that stuff that kind of came into the fold here, because I started to recognize that there were some very real patterns about transmit and receive and isolation, which is kind of commonplace in all other kind of disciplines of RF. Like in cellular, there's an uplink and a downlink band, and with two-way radios, there's an inbound band and an outbound band, and you have band passes and splitters. And so this kind of comes into this world, same thing. You have to kind of look at it as, well, we have an outbound lane, which is the transmit stuff, and we have an inbound lane, which is the receive stuff. So a lot of this became about that. What we did with these early systems was we leveraged it. So I had the A side was PL receive and wireless mic receive, A. And then I had a B side, which was the B side of the wireless mics. So we were double duty on the inbound, on the receive side for receive. Then on the transmit, we were combining 16 carriers and then conditioning that signal in a way to be able to get it low enough to put it and modulate it on the glass, to put it on the fiber, get it over the glass, and then replicate 16 carriers. And that's, I think, of all the things that you have to do with this stuff, that's the hardest thing to do, is to figure out how to get 16 carriers re-amplified. How do you do that? Like, that's a really complicated thing to do. Yeah, and I think in my history of walking into systems that people have sort of DIY'd, and even guys that are new to this, what you're seeing on the screen now, the top picture of that spectrum analyzer is more often than not what you walk into. I can't tell you how many times I walked into a system where I call it self-induced, we call it self-induced, where this might be a picture of, this could represent many things, but in this case, it's overdriving the optical links with the transmit carriers, which then hits the amplifier that's reproducing them, which then creates this spectrum mess, which is all this harmonic and intermod that you see in the bad sort of slide. And then down below, you see a very clear, I don't know if people can see it that well, but there's 3 carriers that are marked with a really good 60, 65 dB signal to noise. And this measurement happened to be at about, I'd say, 10 meters with an Omni antenna. So anyway, that's a little bit of the history of it. I'm just going to kind of change gears and just talk about the MFL, if we can go to that. And this is going to talk about some of the stuff that was kind of picked up along the way on the journey. So there's, in general terms, the RF over fiber market, there's a bunch of players that have produced some different price point, value engineered RF over fiber solutions that can work for certain situations, and all can work for certain, it depends, right? Using Josh's answer, well, that depends. Depending on the scenario, you could get something that's maybe a little more compact form factor, which is just a receive module that has an RF input, a power supply, and then an optical output that connects to another O to E converter back to RF, right? So you got a box on one end, a box on the other, fiber in the middle, RF in, RF out. Well, when you start to get into this, if you get one of those sort of more value engineered type products, which is how I started delving around, which is what we all do. You go, oh, well, RF over fiber. Let me see if I can go on the internet and find some box that goes RF to optical. And so you do that. But then you realize, well, it's wide open, or that particular laser was designed for CATV cable channel distribution. And so the signal and noise isn't really that great. And I'm sure there's a lot of people on this call who know the minute you introduce an active link, like an RF over fiber link, the noise floor just goes right up. And so now you've got to figure out a way to get over all that. And the concept and the ease, or the convenience of using fiber in today's world is just, again, I'm gonna use that word imperative. It's sort of a must. Like if you can leverage fiber, because we're putting in all this fiber infrastructure on shows. So I'm gonna try to limit this here, but looking at this slide, I was talking about just the baseline optical conversion, and you can, I don't know how well you can see this. I don't know if you can actually zoom in that a little bit, or if we have a slide that just shows the MFL. But anyway, you can see that there is, in this case, there's actually 4 RF channels. So instead of having a single channel in a small box, this is kind of a block conceptual diagram of a Wisycom MFL system. It has 4 channels in it. It's configurable at the factory to do, you could have 4 transmit lasers on one side and 4 receive on the other. Typically, and the intent here was that you would typically use 2 receive and 2 transmit. Now with quadversity, we're seeing, we tend to do more, we may use 2 layers, actually 2 MFLs side by side. 2 of the receive are the A and B, and the other 2 are C and D. But the baseline intent here was A and B receive, and then the transmit. So 2 in one direction, 2 in the other direction. In this case, there's also an optical mux in here. So instead of having 4 lasers and using 4 strands of glass, there's actually a mux that multiplexes these 4 optical signals. So you can use a single strand of glass between the 2 endpoints. the bigger part of the MFL, what makes this unique is the signal conditioning that we do before we get into the glass. And every scenario is kind of a little bit different. It's all about, again, we were talking about control and dynamic range. Like I want to be in a situation where I can control every element of what I'm about to walk into. And this comes from, as the guys on this call will know, this comes from years of not having control. Like I'm just going, well, I need to insert another pad, or I need another amplifier. I need more gain or I need less gain. I need more filter or I need less filter. So instead of having to put question marks on all that stuff, so if you just buy the O to E and the E to O, you know, you'll spend X, but then you're going to spend to get X to work the way these work, you're going to spend another, you know, umpteen. You're going to have to figure out all this stuff, which is already in this box, which is the first stage is a filter on the receive side, which is that going back to that tunable filter section we talked about earlier. It's the whole BFA front end. So you've got all these tunable filter options for the receive side. You've even got a loop out for external fixed filters. If you want to, if you're a fixed filter fan and you have your own filters already, you can loop out of this thing and just do that. And then there's optical level, there's RF gain, signal gain on the input level, then or filtering, then gain control, then it goes into the optical link. When it gets to the other side, you've then got RF gain again, which then you typically would feed this into, say, an MAT288 combiner. On the transmit side, so the receive signal chain, you've got all the dynamic range processing that you need, and you can do this through a GUI. So we talked about this earlier. You know, if you're setting up 6 RF over fiber zones, if you're doing a massive footprint, you want to be able to just configure and commission the system and dial it all up, and you're done. And anybody who's a kind of at the pro level in the industry knows that this is kind of pretty much the only real way to do this efficiently. Like you can do it, you can get it done other ways, but and talking about what we talked about in the beginning, the idea behind the MFL was not to design the cheapest box. It was to solve a very real RF problem and a logistics problem, and do the best possible, you know, come up with the best possible engineering solution to solve this problem of remote RF over fiber. So you got all this received signal processing, it built in, optical, laser, current, temperature, all this stuff is all built in. On the transmit side, or what we might typically use for transmit side, there's, and this is true of both sides, but you've got sort of dynamic range presets. Depending on what you're doing, you can set it up for receive or transmit or whatever you're doing. On the transmit legs going back, it's the same thing. You've got gain at the input, and then you've got gain at the output, pre and post laser. And then recently, Wisycom introduced well, about a year ago, I guess. It's called a PAW, and this is kind of the art form. There's a product called a PAW, which is an amplified antenna, which has a you can basically reproduce a single carrier at 250 milliwatts through this. So if you want to send an IEM or an IFB through the transmit side of this link, get it back to the other side and get 250 milliwatts, and it's an off-the-shelf solution. Recently, they came out with a 1RU box, which is called an MPA4, that can be used as the amplifier stage at the remote site. So the hardest part of all this is reproducing the carriers at the remote end. So if you combine, let's say 8 IEMs, and combine it and put it over fiber, quick note is you're gonna have to pad it, and you'll probably use the attenuator built into the MFL. You get it over the fiber, and then at the other end, you're gonna need to amplify it. And that amplifier is kind of the magic, it's the secret sauce. And the MPA4 now makes that an off-the-shelf solution. The only caveat to that is that you can only get, in theory, 4 carriers per channel, but it's a 4-channel box. So you got 4 in, 4 out. So if you have, in this case, with an MFL, and I know I'm talking fast, but with an MFL, you've got 2 transmit layers that are able to ship back out to the remote site. So that if you did 4 carriers each, that's 8 carriers going into the remote end, which hits the MPA4 amplifiers. So now you've got 8 carriers. If you do what we do oftentimes, which is use a stereo carrier to support 2 IFB channels, that's 16 IFBs off the shelf. transmit. 16 IFBs off the shelf, which is a big deal. I mean, this is advanced compared to where we were, say, 10 years ago. None of this was off the shelf. I mean, and it's clean. You can do this and it's clean. I mean, it's like clean, clean, clean. Well, I'm gonna say one other thing about RF over fiber transmit and amplifiers. It's not a perfect science. If you took a spectrum analyzer and walked up to like a meter, 3 or 4 feet from a transmit antenna off an RF over fiber system with amplifiers, you're probably going to see a little bit of an elevated noise floor. If you've done your job well, you're going to see a little bit of an elevated noise floor. So you wouldn't put the antenna, the transmit antenna, a meter away from whoever you're trying to receive. You typically would get a transmit antenna up in the air, and you want to keep 30 feet or so. Just get it up and out of, which isn't unlike things we've seen in the past with, say, BTR 800. You couldn't stand too close to it because there was all kinds of crosstalk and everything. So you have to move away from the base station. So when you're doing RF over fiber transmit, there's a little bit of that RF common sense, which is don't stand right next to a transmit antenna with an amplifier on it. It's just not going to perform well. The idea is there's a practicality of this. There's theory, and there's letter of the law, and there's room for all that. But in this particular instance, you're going to want to distance the transmit antenna, 6 or 8 feet, not any different, 10 feet maybe, not any different than the way you need to separate transmit and receive antennas if you're doing an IEM rack and a wireless mic rack. You just want to have separation. So that very much comes into play with transmit receive on fiber. Done. Drop the mic. So.
All right. Hey, let's. Dave had some comments about the MFL too. So some stuff to add to it regarding fiber and whatnot. We had a couple questions about.
That's probably a good slide right there. I'm going to touch on a couple questions that came up. I'm going to work backwards in relevance, unfortunately, but we can hit all of them. Philip Barrett, you had asked about doing mono carrier or mono IFB over a stereo carrier and what the crosstalk is. And there's a note here, what about with PSM 1000? It very much it considers the type of gear you're using. PSM, in my personal experience, and I'm sure some of these guys can chime in, there's pretty bad crosstalk on the P10R. P9R is actually even a little bit worse, but that has a lot to do with gain structure. If you're hitting the transmitter super hard, it's going to bleed right through, and you'll hear it kind of crossing over. Depending on the device, there are certain things that are set up for that. The Duet is set up to do that, and it can be synced right into the receiver to just pick up channel 1 of this TX. The NPR 50 IM and NPR 50 IFB, which is a slightly cheaper version of the belt pack. Josh has shown it off there. It's able to go into that split mode. They call it mixed mode, similar to a lot of companies that are out there. Mixed mode, split mode, the language is usually pretty much the same. So mixed mode is a crossfader where it could be placed into mono mode, and you're actually just saying, I want left channel, and that's it. And that's all the container is going to give you. And it's actually doing that to save some of the battery life on there. The MTK is very good at it. I see a follow-up question popped up here. MTK NPR combo is really, really good at it. The Duets do it well. The PSMs can be tamed, though. It's just all about your gain structure and kind of getting that right. Oftentimes, if you're coming right out of an Atom or something like that, it's pretty spicy. It's pretty hot hitting those inputs, and drawing it down a little bit and just using some of the gain on the receiver, put it into high gain mode. You're able to make up gain loud enough your talent won't complain, but you're not blasting the front end and hitting that companion so hard that you're gonna get the crosstalk going. So it's a little bit of give and take there, where some of the other platforms that are out there can take it a little better.
I think also, Dave, just to be fair, I think the latest version of that Shure has, they're doing FMDSP, which actually addresses some of this.
So that's on the Plus, the P10R Plus?
Yeah.
Yeah, that's got a whole new front end apparently. I haven't. Ryan and I did an install recently with those, and we didn't have any real issues with crosstalk. There was one issue where it was coming out of a RedNet box just 5 times as hot as every other channel on there, and that was bleeding into the adjacent channel, but it was just kind of a fluke thing. But yeah, watch your gains. It's doable with pretty much everything. And like Jim said, the RF domain has changed so much that this isn't an uncommon trick for us anymore. We want to keep our carrier count down, because I look at it is how exposed are you in some of these environments. And if I'm putting up individual IFB carriers when I don't need to be, that's just more exposure. That's more chance for some issues to come up there, where I can be a little bit more selective with my frequencies and pick those ones that I know are going to be really good, really high SNR, really low noise, and that I can just find more success with. Matt, you had asked about exploring WDM technologies with RF over fiber, and possible solution to transmit over fiber. So that is something that's inherently built into the MFL. They have 2 different versions of the MUX that are built in, but right off the bat, it's using the built-in channels that the box uses are all wave division channels, and then you're able to get a MUX with available auxiliary channels, as they call them, and that allows you to put more devices through the fiber link that the MFL is using. Common example might be to throw like a Aja Fido through the thing, because those operate in the wideband section of the kind of WDM schedule there, where you're looking at 1260 to 1360 nanometers. A lot of the common just kind of, it has one ST connector and it does one job. Most of those are in that range. There are some specific SFPs that you can pair up with the MFL that allows you to put it into pretty much anything. And when I say anything, I mean like free speed splitters, switches, anything, because the fiber doesn't care what the media is. It's just fiber, as long as it is on the specific auxiliary channels, which I think on the fully loaded MFL, that you've got the 1310, which is the 1260 to 1360 wideband channel, as well as 1590 and 1610. So we've got a couple, big stack of SFPs from Finisar in those specific channels, and we're just packing more stuff in on our devices. Jim touched on a box, the MPA4, and the MFL. The way you can think about an MFL is it is a frame, and it can be configured in a bunch of different directions. We touched on that, and that kind of has to do with the model number. So an MFL TTTT, for example, is all T's outbound. So the application for RF over fiber using an all Wisycom kind of tool chain and the MPA4 is actually to use a non-muxed version of the MFL. And then at your head end, you would feed channels in to identical units. And then we would actually optically mux the same channel. So a good example for this would be I'd have 4 TTTTs, right? And the Wizy MFL lasers only operate on 4 very specific channels: 1510, 1530, 1550, and 1570. So I can take 2 of the same wavelength laser, and as long as they don't have the same frequency on them, I can optically combine those. And that's an application that was developed in Italy for doing an insane amount of RF carriers through the MPA4. The MPA4 is a very powerful, small device kind of for this application, because then we'd be talking about doing 32 individual IFB channels, even more. Out the other side of the link. We're way down a rabbit hole on what you can do optically, but optical combining, optical splitting, and kind of optical circulation is very similar to RF, and a lot of the same rules apply. So leveraging some of those technologies is definitely a huge way to really push the field of transmit over fiber. And Wisycom they heard that, and they answered the call there. So Not only is this stuff available, but these options for optical combiners, optical splitters are available to be built into the MFL. So definitely heavily leveraged by Wisycom for sure. The issue with that and a lot of the stuff that's out there, there's a lot of RF over fiber companies out there. There's our peers and our friends and companies that are building them. You've got PWS, RF Venue, they have products. There's the entire military kind of complex that a lot of this stuff is built around for defense applications. Not a lot of focus has been put into wave division in our domain, in the audio domain, and in UHF, and what we're trying to do for production RF. Where Wizy is able to kind of run with that is they don't buy an off-the-shelf laser and slam it in their box. They're not buying it from another company. Their lasers are built from the ground up to be in an MFL, and that's kind of a big part of why they have so much control and why we've had so many successes with the system.
Dave, can I throw a question for you to answer?
Yeah.
Just because I kind of know the answer, but I know you'll be able to speak to this, is in general, like for the people that have actually, we sell the stuff, so we support a lot of people that have it. Some of the bigger questions that come up when they start to implement, and especially around housekeeping of fiber and that sort of thing. Just, fiber housekeeping as it relates to this, and
well, it comes up a lot.
Bad fiber versus good fiber, or in between fiber, and like what impact that'll have.
Well, you look at applications that a lot of people are familiar with fiber, and where they might have come across it, even as audio or doing, there's a lot of crossover in comms. As you're looking at this panel here, you've got some more audio guys, some more comms guys, and it's all blending together these days, especially in this field in RF. And you're used to dealing with LC connectors and plugging them into switches, and those are pretty tolerant. And doing some free speak over fiber is pretty tolerant, easy, and even doing cameras, it's kind of plug and play. It might be a little dirty. You give it a little, and put your little clicker in there and clean it out. The difference here is RF over fiber is strictly analog sampling end to end. You're not digitally sampling something, sending it across a line, and then reconverting it on the other end, right? So it's way less tolerant to any points of reflection or attenuation that you're going to see in your link. Now, if we're looking at a link with dedicated SC APC connectors, which is what the MFL uses, which is the green square, say we have a TAC4 of that and we go end to end, we still have bulkhead connectors in the back of the unit. There's potential for reflection there. Now, often, and we'll throw it out there, every setup we ever do, the first thing we do is convert it to ST, right? Because that's what, if we're showing up, any truck's gonna have ST, any production that's coming out is gonna have ST. And it creates a lot of points of reflection. And what's happening with any of those points of reflection, especially the ones closest to your laser, the first thing that light's going to do after it hits that flat ST connector is bounce straight back at the laser. And that's when you're going to start seeing noise and unwanted performance and kind of odd behaviors out of the system. And driving the laser, yeah, there you go. Josh is holding up a Sam Charlie connector right there. And if it's going to be hard to see, but the tip is actually angled on that. And that's angled in a manner that when the laser hits that, even if there is reflection, it's just going to reflect into the side rather than bounce 180 degrees right back at your laser. And that's when you start seeing your laser getting overdriven, and you start to see some of those, that kind of terrible noise floor and that bad picture in the frame that's up right now in the presentation. So what that means is with your links, you have to take very, very special care of how you're laying your system out. You know, a situation like you were talking about, golf, Jim, is a great example where you're going through somebody else's fiber, or it needs to go through a bunch of patch points. Each one of those patch points, you know, if you're going in a studio, anything like that, that stuff's not maintained that well. And it's going to bring up a lot of questions into your link, where before you'd kind of be plugging this stuff in and hoping it works. If it's a mission critical show, we're bringing an OTDR to see where all these points of reflection are. You threw out Disney Parade as a great example. We don't have control over fiber when you're in Disney anything, and you can't even clean a connector. They don't want you touching it.
Yeah.
But you talk to the guys who are hooking your stuff up and go, how many points are there between here? And they're like, oh, it's 21 different butt connections between us and the fire hydrant across the street that you're trying to get to.
Yeah.
You have to take a lot of consideration for that. The MFL does have AGC that's happening in both the RF domain and the optical domain. So it'll compensate for that. And that's something that we've just beat to death at the shop. A good example is taking a handful of barrels and just end for ending a TAC-24 over and over again between the two links. And the MFL is able to compensate for a lot of that loss, but it's the reflection that's going to kill you. If you have dirty connector faces and it's not able to have a good mating surface there, that's where you're going to generate a lot of that noise and get very unlinear. We like to tag it.
Just want to throw it, like my show experience when we were building these systems and testing them out. I always found to test the fiber I was going to use on the site with the RF equipment that I was going to use. You know, with
Absolutely.
Yeah. If you can do it, like test everything end to end completely before you get to the show. Even if I've also found if I were going to deploy some TAC cable, I would try to test it all in the compound first. Even, I mean, we have optical power meters, but we also have, you know, visible light and stuff like that. But I was always just so conservative about plugging everything in before I deploy it, because once you get it on the other end of the, you know, the park or whatever it is you're trying to do, it's the other end of the arena. Now you're walking, you know, if you have a problem. So you want to make sure that glass, in my opinion, is tight. You know what? Just one thing I want to throw on top of what you're saying. Somebody said something about RF over fibers, that it's subject to linearities. That's the term. It's very subject to linearity. So it is impacted by a lot.
So talking a little bit more on that point and some of the notes that are in here, something that we've come up with sub rentals that have gone out and sales that have gone out of the Jetwave shop is we'll get a phone call that, hey, the MFL just doesn't work. The power meters say I'm not getting anything. Those reflections and issues with your fiber are compounded when you're doing wave division multiplexing. You've got a lot more potential there because it's one connector to cause issues with your light wavelengths going in either direction. So oftentimes we stick to the very simple stuff. Carry a scope, use wipes, solvents go a long way. Do not put click pins inside bulkhead connectors on an RF over fiber system. We can say that for the MFL for days and days and days. It goes for anything. Putting a click pin inside a bulkhead connector is a great way to introduce oil, dirt, grit to that connector. That's either going to cause backspacing issues with the connector mate, or it's just going to put a sheen on there that's going to create reflection in either direction. So keep it simple, inspect your fiber every time. Like Jim said, it's really important to just kind of do that first. Especially before you lay out like I don't know, a 2,000 foot TAC-12. You don't want to do that again because, you know, it got run over by some forklift before the last show and it wasn't QC'd correctly. Taking the time to deal with your fiber takes a lot of that kind of mystery out of it. I know my path is good, so I know if I'm introducing a bunch of noise and I know the fiber is good, well, then we probably have some gain structure issues. We may be overloading the front end of the laser, And a lot of that just comes back to knowing your bits. No matter what fiber system you're looking at, look at the tolerances. Know what that tolerance means. If it says, you can hit it with a plus 15, know what that looks like, and know where that lies, so that you can take a lot of the mystery of just slamming an ST connector in and going, yep, I got RF, and staring at lights on the front of a rack. That's you got to have more intel on your system there to know where some of your problems are and to avoid some of them. This kind of brings us back to Brad asked the question very, very early on. Brad Gavin asks, when looking at your MFLs, do you expect to see deviation in levels on your fiber on the receive end? Or if it is fluctuating, is it completely indicative of dirty fiber? That could be a few things. Looking at your question, we can kind of unpack that a little bit. The MFL is able to give you metrics on both the optical receive power as well as RF receive power. Now, RF, keep in mind, if you're not filtering at the front end, you're looking at everything from, could be as low as 150 to 1160, but oftentimes the default's going to be you're just on UHF or something, but that's a lot of space, and that includes two ways. It includes a lot of that kind of noise floor you might be picking up. So the first thing I would look at would be the front panel, my RF power levels. I know that I should see a certain amount from one end to the other. An MFL, depending on its spec, but most of them have 4 milliwatt lasers on the front end. And we're going to take about a dB and change if it has a mux in it of kind of, we'll call it combiner loss in this case. Now, so I'd want to see maybe 2-ish on the other side, maybe 1.5. If I plug it in, my noise goes through the roof and I see my optical power is at 0.45 milliwatt, I know what to be looking at. I would be looking at fiber in that case. Something that is buried in the menus of the MFL is an optical loss calibration, and that is before you leave for the show, take a clean, known good jumper that's only a foot or two long, maybe a meter tops, and you can hook them together, your two units, and your head end and your remote unit, and actually calibrate it to say, this is flat, this is good. And then when you're hooking up to your TAC on site, you can actually jog over and it will tell you how much loss you have end to end. And then it would be a good time to start looking at connectors if you're seeing a lot of optical loss. Now, if I don't have a lot of optical loss and I'm seeing my RF all over the place, I'm probably going to go further up the food chain, start looking at antennas, cabling, if I have any filtering or LNAs external to the box there. That's kind of what, let's see, something, Josh, if you wanted to go back to the master slave MTK page, this comes in with our RF over fiber system here as well, because it so neatly says coax or fiber. Henry Cohen, you asked a question about an MRK set to slave mode for rebroadcast to the master's carrier. Is its oscillator synced to the master for true simulcastability? So,
MTK.
Yeah, MTK, sorry. Reading too many questions at once. The relationship here with the master and slave, when an MTK is put into slave mode, it's actually bypassing a couple parts of that unit. So MTKs are DDS, or direct digital synthesis units, for kind of the actual RF synthesis. Then it goes through a double conversion stage, a lot of filtering, and then a parallel power amplifier output stage. Right, so those 3 bits would make up your master unit that's actually generating the RF, so to speak. When it's in slave mode, we're bypassing the DDS circuit. We're also bypassing the conversion stage. So it's just going into the power amplifier stage. Now, the power amplifier stage is multiple parallel amplifiers utilizing a lot of phase conversion and trickery to reduce some of the early stage intermod before it ever actually leaves the box. So to answer your question,
Is there a tracking filter as well, Dave? Like right at that, I think the slaves tracks the frequency.
There's a frequency counter that will tell you what's going on there, but it is directly coupled to the output stage. And that is why you can, and we've tested this ourselves, you and I, put 4 carriers of a reasonably wide envelope into that.
Yeah.
Now, you're still only going to get your certain amount of lift out of the amplifier. As I add more carriers, I'm going to get less amplitude overall, especially as I open that envelope up. But because the slave isn't actually doing any synthesis, it's just a power amplifier in this case, it is completely in sync with our master unit. Now, this can be copied and pasted all over a large antenna system, and as a result, since we're only the DDS and conversion stage and the master unit is responsible for that RF synthesis, now everything is completely in sync. We don't have any problems, in short, with doing these transmit distribution systems using the slave model. Now, that same trick can be done with the PAW, as Jim mentioned, the individual little power amplifier brick. That can be placed on the other end of a fiber link for the makeup gain as well. In kind of the same fashion, because all of our FM synthesis is only happening at one place, everything is in sync. So I don't want to say we're reckless with overlap of transmit antennas, but I am not as careful as I was previously. And oftentimes we're leaning more on stuff that was kind of a little more taboo, like just throwing omnis up everywhere. We've just had good results, and I rely mostly on my personal experience and with a lot of this gear. Doing the master slave trick has given us some coverage that not only exceeded the production's expectations, we're doing walk tests like blocks away, just dumbfounded that it's working so well. So I hope that kind of answered your question there, Henry, about what's going on in the relationship between the master and slave units.
Can I chime in? The correlation between that amplifier stage in the MTK 952, the amplifier that's in the PAW, which is a single channel amplifier in kind of an inline form, the amplifier that's in the MPA 4, which is the rack mount unit, which is actually 4 channels, 4 amplifiers and 4 channels. All those amplifiers are pretty much based on the same piece of technology, I believe. I think they're all basically the same amplifier that they've kind of repurposed into different form factors to create building blocks. The idea is to have building blocks when you get to site and have agility. Like we've talked about this, it's all about being able to have control over your environment. So these all these different various tools kind of give you you can always pull something out of your pocket, because whether you grab an MTK for a slave, or you have a PAW amplifier, or you have an MPA4, which is kind of the Mac Daddy. You got all these different options to just throw an amplifier at the other end of something. So anyway.
So kind of putting a bow on some of the MFL topology and technology. Josh, if you want to jump back over to slide 21, that same MFL one.
Slide 21 of 233.
Yeah, we're just getting started. We are kind of winding down here, but kind of wanted to zoom out a little bit on the gear and an MFL system compared to a lot of the other off-the-shelf systems that are out there, whether you're looking towards that kind of defense facing stuff, the really common stuff you see, Violite and a lot of the more common brands. When you look at the cost of an MFL system, it is alarming at first. But when you start to add up the sum of the parts, like Jim was talking about, well, I can have the box, but then I need the attenuator, I need a filter, I need all of the stuff on the outside. The cost effectiveness gets pretty close pretty fast once you start adding all the widgets to, if I wanted to recreate this with some other pieces that are out there. But Josh touched on this very well, and that's, you got to look at the ROI on this. And I look at it mostly as a labor savings system. we are not running around like we used to with the Bexel fiber system. You know, lots of going and checking something. Oh, this FC connector is slightly loose, so something's off. There's a lot less touch because of the intelligence that we're able to bring to the system, and that means we can usually show up a little bit later, be up a little bit faster. So there is a trade-off there on the ROI. And it does kind of come back to the one question that came about from Stan, the different levels of RF production needs. When you're talking RF over fiber, you're probably looking at a larger production. You know, if it's for this one hit they need to do at the top of the show, it's, well, okay, just use the ENG mount receiver and move on with your life. But if you need to bounce back and forth between different remote sites and are all over a large area, you can't really do it any other way and still maintain true flexibility of the gear. That everything, everywhere mantra, it's what TDs want to hear. It's what productions want to hear. Oh, we don't need to swap IFP. No, they can literally just walk right in there. It's the same thing. It's all the same. Same fader on the mixer, same key at the atom. It's so while it does kind of get brought up as being a really premium, very expensive product, it does have a place in a lot of productions for sure.
Also, building infrastructure, you know, doing big buildings and distribution around buildings, it's probably the only way to do it, I think.
Let's see, a few more questions popped up. Pete, are there optical isolators in the MFL? There is not a separate isolator, but these are direct feedback lasers. So it's measuring input versus output and doing a little bit of AGC in both the optical domain and the electrical domain to compensate for some of that reflection that's coming back in.
I meant optical isolators to prevent the reflection from coming back in.
No.
Typical optical isolator rotates the light signal 45 degrees, so the reflection comes back in 90 degrees out of phase.
The MFL is doing that more on the laser side. Really good question that popped up from Nat is about the E to O and O to E conversion again. So what Wisycom is doing is all about maximizing your dynamic range. And dynamic range of your kind of RF reproduction from end to end happens in both the RF world, the electrical domain, and in the optical domain. So if you're doing that on both sides of the conversion, you're able to have incredibly high dynamic range across your link, which allows for much more faithful reproduction on the other side. So going end to end, at my antenna input, the MFL is going to be monitoring and making small adjustments in game prior to the input of the laser. It's then going to measure that again at the photodiode at the other end of the laser link, and also be working to maximize that dynamic range before going on linear, as Jim was talking about, and causing some of those noise and overdrive issues that you'd see. The same thing's going to happen again after the photodiode before it comes out of the box. You're going to have a little bit of conditioning going on again. And you can actually see that real time as you grab patch cables and bend them, or kind of overloading an antenna intentionally, blasting a two-way right next to your paddle. It's able to do this while remaining easily one of the most transparent links we've seen. The only time you can see it real time doing anything is if you slap a pad in real fast on a link. You'll see it come back low and then jump back up. Let's see, Pete, click pins are mechanically bad for APC. I wholeheartedly agree. Click pins are the devil. I much prefer wipes or cassette style where you take the connector onto it. I think click pins are fine for external connectors that you can see, but once you start jamming them into bulkheads, you got to think, can I get to that other side of the bulkhead? If it's your rack panel, that's one thing. Inside the MFL, you don't want to be taking that apart and getting down into the 9-micron unsheathed fiber. You don't want to be doing that on a show site for sure. let's see, KP. In my world, for RFoF is always separate of other fibers being deployed on a remote. We do this intentionally to avoid problems with other fiber gear supporting other needs. We try to do that as well. Oftentimes on shows, though, it's well planned ahead of time, and then you show up and they go, "Oh, we want to go by this tree that's way over here, so we're just going to throw you on this TAC-12 with everything else. And can you move the zone during the show to do that?" And
Isn't it oftentimes we're sharing like a trunk? It might be.
Yeah, it might be like a TAC-12 or a TAC-24, and
Yeah.
we're sharing it with cameras and camera sheds and other, other stuff that's going out there.
We have our own strands, but
I totally agree. KP says, but what's the cost of an on-air production failure? Tell that to the guys holding the checkbook.
Yeah.
But yeah, we stock our own TAC cable for that exact reason. Is whenever we can bill for it and get it on the show, we're always trying to be on our own, and then we will nicely hand out a strand or two if somebody needs it. But since we maintain our own inventory, it's able to help us keep that control and that intel I was talking, not walking in and just getting some crap TAC-12 that's never been cleaned or put on an OTDR since the truck bought it. How do you clean those bulkhead connectors, John Christie? If you go, a good example is I got an MFL back to the shop in Alexandria, and they said it doesn't work. And if you hook it up with a patch cable, the optical meter says 0 milliwatt to the other end. And what I did is you have to pop everything apart, and you have to start looking at what's on the other side of the bulkhead. And this isn't just an MFL. This is anything box with a fiber connector on it. That click pin is not going to clean it in a manner that you can really get in there for. There are some awesome tools out, great small video scopes that actually have a ferrule on them that you go into the barrel and see what's going on. Oftentimes you're going to find it's dirty, it's got oils on it, it's got grit on it, and it's a shame that the first link in your chain coming out of the box would be the source of the problem. So that's why it's good practice to not get into that bulkhead and do a breakout for it. Take a patch cable to something else that you do have access to and do have control to, and don't unplug that when you're in there. Yeah, so Pete's showing off a JDSU USB video fiber scope, which are, I'm not going to say they're cheap, but they're pretty low cost and incredibly high quality tool.
Yeah.
They come with a number of different ends that can go into angled connectors, all different style of bulkheads, into SFPs. They're great.
Hey, Dave, I just want to jump back real quick. I know, and then we'll be done. I just want to throw something out about two-way radios and RF over fiber and distributed systems anyway. In general, two-way radios are probably the biggest enemy of the RF over fiber system. And generally, because it's a 4-watt radio, and if you think you can filter a wireless mic receive window at 470, and then put a site in the middle of a very, very crowded area where there's a lot of two-way traffic, I think you're going to find very quickly that the 4-watt radios are going to kind of blow out the lasers. And so ideally, you want to pick your receive window to start maybe 15 meg. So give kind of a guard band so that 10 meg or 5 meg, you can play with it a little bit just by using a two-way radio to see what it's going to take to blow up the front end of that system. And the way to check it is you're looking at a spectrum analyzer on the output of the system, and you're keying the radio in front of your receive site, and that's how you're kind of protecting yourself when you get to the production into show time from some security guard coming up, standing right under your site, which is what's going to happen. And he's going to key his radio, and he's going to blow your front end out. So that's just something kind of a, I didn't read
That's never happened to you, right, Jim? I mean, really hypothesis, right? You just hit you just now.
No, it's not. If you didn't, if you never heard that and you didn't know, I don't
exactly.
People don't know that two-way radios tend to be from 450 to 470 generally. Most, right? And most commercial radios that we see off the 469, right? .5. So, and we're starting our window at 470, but we're these, little 25, 50 milliwatt transmitters, and they got 4 watts, they're just going to burn a hole in your RF system.
Now,
Yeah.
that's interesting you bring that up because that kind of falls right into that slot, with the slogan I have, the knowledge learned and the knowledge earned. And I'm pretty sure
For
you
sure.
earned that piece there because, over and over. And I gotta say, what you brought in today, this was definitely that deep dive that so many people are like, hey, we want to focus. You did just such a great job. I had a couple notes that I made while you're presenting. It really had nothing to do with the actual hardware itself, but a few things. I looked at a lot of the attendees because I have that privilege as the organizer to see that. And what's so amazing to me, I've seen this week after week now, that our peers are connecting. Obviously, you named a few of them in your presentation, but I think the powerful statement is you guys coming on, sharing your best practices, right? During this time when we all have a little more brain power open to amass things, but that's the strength of our system and the strength of our industry is that we're not afraid to talk about things that a lot of people would normally just, hey, I'm going to be over here in the corner protecting, what I think is whatever. And so I want to thank you for that because you've set a really great example. I also looked at a lot of the people that are watching, and I would say to them, and you know who you are, you should be partnering with a Jetwave Wireless when you're doing a project. I mean, a lot of great questions, but in so many ways, why reinvent the wheel when you can walk in and, KP made a good point about what's the cost of failure, right? Well, actually, it's priceless. You can't put a number to it because there is no way to calculate that. But this is something where you have that ability to partner, to bring in someone like a Jetwave and say, hey, this is a one-off for me. Maybe even it's a two, but bring in your solution. I think the Cat agrees with me, and I can't agree more. The power of the user vendor with the manufacturer. Man, did we see that here? That Wizzy this is a box that you can tell reflects the passion, number one, for this area of RF, but also everything you've done to help influence that. And then finally was just choosing the right people for a project, right? This just goes to that point. Be the smartest you can be in whatever you're doing, right? And be the most passionate about it, because ultimately at the end of the day, it pays dividends. And I think we saw it here. Thank you guys. So much appreciative on that. Pete, you got anything to say here?
I think my biggest takeaway from this goes along with what Josh said about ROI. If you design your systems for the worst case, before when you go in, if you say, okay, I'm going to put antennas and receive and transmit areas everywhere I think it might be used, or at least be ready to get them out into the lobby or ready to get them out into the loading dock very easily, you can only look good to the producer. You cannot look bad to the producer. The producer is used to thinking RF is magic and it can't be done. And if they come to you and say, well, I want to have the talent walk down 48th Street and we're not covered there, right? And you say, no, I'm ready. You know how good that sounds to the producer? It's amazing. You can't beat that. And the only thing that makes that possible is equipment like Wisycom that's so easy to put, to expand forever, which you couldn't do any other way. Used to be you'd put another receive rack somewhere on the other side of the rink or something like that and feed the audio, because there was no nice way to get the signal back and forth. This year, or last year technically, for Macy's Day Parade, for the first time ever, I've been doing it for 10 years now. Josh had been with me for maybe 5 or 6. We always used to put all of the hardware up on the stage on 34th Street. And this year with Wisycom, all the hardware went right next to the truck. There was no issue about getting the audio back and forth to the stage. We didn't have to negotiate for audio channels, whatever. It was all there right next to the truck, and all the antennas went over fiber provided by the production company out to the stage. And it was, and Josh stayed out on the stage and controlled the whole system over his computer on the network. I didn't have to put down my book ever.
Well, it sounds
Picked
like
up
you were
repeat the
there
most
for
this year.
good moral support. And,
Oh yeah, definitely,
as
definitely
always,
immoral
Josh
support.
was
Yep.
doing the work. Yes, understood. Sorry, I
Exactly.
didn't mean to say that out loud.
Somebody had to protect the catering truck.
There you go.
Yeah.
Exactly. But thank you again, everybody. There's the contact information up there on the slide. Really, really great job, great preparation, great topic. And as always, let's keep sharing across the industry those experiences, and thanks for sharing a couple of the bad experiences that help us to do our jobs better. So that should wrap us up. What do we got tomorrow is more comms. We're talking Telos, IPA, AES67 comms. Then we're going to go into Pliant and crew comm. So just always about comms and RF somewhere. It's you'd think that we do that for a living or something. Anyhow,
No.
that's it. You know, everybody go have another one. Thanks for coming prepared, Josh. You now win along with Staffo, right? With his wrestling attired RF Faraday. Oh, and there's the third one. So this is closing round. We definitely now we got to stay on so we can get Josh's real feelings about things. We'll pop a few more down. So anyhow, and thank you again. Thanks, Ryan. Thanks, Dave. Much appreciated. And Jim, of course, we'll look forward to chatting as we continue on, and we'll be looking for you on the other webinars.
Thank you so much.
So long, guys.
Thanks, guys.
Good night.
Bye-bye.
Bye.